have a question for you before we go into the solution of this problem here. Which among these forces, force is constant, a varying, or an average force, would you choose to solve problems based on impulse momentum theorem? Which among these three would you choose? Okay. And while you think about it, let us quickly try to visualize what is given to us here. So a player caught a cricket ball of mass 150 gram. So this mass is 150 gram, moving at a speed of 20 meter per second. It is coming at a speed of 20 meter per second. If the catching process is completed in 0.1 second, so this duration before catching the ball and after catching the ball, this duration is 0.1 seconds. The initial velocity is 20 meter per second. And of course, since the ball is being caught, the final velocity would be equal to 0. So if we understand the initial conditions, mass is 0.150 kilogram. Initial velocity is 20 meter per second. Therefore, the initial momentum would be mass into initial velocity. Mass is 0.150. Initial velocity is 20 meter per second. So 0.150 into 20, 150 into 20 is 300. 1, 2, 3, 4, that gives us 3 kilogram meter per second. Right? Now this is initial condition. Before catching the ball is still in the air. Now, the final condition, the ball has been caught. Mass is 0.15 kilo, 0.150 kilogram. Velocity is 0 because the ball is at rest now. Therefore, the final momentum is equal to 0. Right? Now, during this transition, from the initial condition to the final condition, the change in momentum is from 3 kilogram meter per second to 0 in just 0.1 seconds. Therefore, the change in momentum is final momentum minus initial momentum, which is 0 minus 3. And therefore, change in momentum is minus 3 kilogram meter per second. Now, we get negative in the change in momentum because the direction of the ball's motion is opposite to the direction of force. That, of course, is something very clear to you. And we have also assumed that the ball is coming like this horizontally and the ball is being stopped exactly using horizontal force, or the ball is dropping vertically and is caught vertically like this. Okay? Right. Now, with this in mind, by impulse momentum theorem, F dot delta T will be equal to delta P. Delta T is 0.1 seconds. Delta P is minus 3 kilogram meter per second. Again, vector notation is really important here. And therefore, what we get is vector F is equal to minus 30 kilogram second by second is second square, kilogram meter per second square, kilogram meter per second square is Newton. So we get F is equal to minus 30. So kilogram meter per second square, kilogram meter per second square is otherwise equal to Newton. And since this is the vector, if we take magnitude on both sides, what we get is 30 Newton is the force acting in the opposite direction. And the question very particularly says it is the magnitude of the force, which is therefore equal to 30 Newtons. Okay. Now, that was the solution to the problem here. But we started with this discussion with something else. Yes, exactly what was said. The three different modes of forms of impulse momentum theorem, force and impulse momentum theorem, right?